Welcome back. This is Jeff Byers, and this is Annie 255, and we are now on Module 5, and we're going to create a simulation called Put Out the Fire. So the whole idea on this one is that we're going to be taking all the skills and learned information that you got from the previous modules, and we're going to place them all together into a lot more involved scene. Even though it doesn't seem like it is, we're going to have 4 different dynamic or VFX or visual effects going on at one time. So basically, we're gonna have you model and texture an interior of a warehouse. We're gonna have you model and texture a fire hose nozzle, hose, and 5 boxes. You're gonna learn how to create fire effect using the Maya effects, and we're gonna have you create a water simulation to put out the fire. So that's going to be a particle simulation, and then we're going to do passive rigid body dynamics on the floor and the walls. And so we've got, again, 4 different types of effects going on. So we've got the boxes will have the active rigid body dynamics on them. The boxes will also be placing a fire effect on the boxes, and then the water will come out of the fire hose, and that'll be a particle simulation. And then we've got to put a passive rigid body dynamic system on the floor and the walls. So there's 4 different things that we've got to work, and there's a certain way to put it together. So that's what this is all about. So basically, the idea here is the student will create a water simulation where the particles hit the boxes, knock them over, and put out the fire. That's basically it. So you guys can read the objectives and all that. So I'm just going to kind of skip through that part. I've already went through the overview with you guys. So basically, what are dynamics? Dynamics is a branch of physics that describes how objects move. Dynamic animation uses rules of physics to simulate natural forces. You specify the action you want the object to take, then let the software figure it out to animate the object. Now, Maya has a very robust dynamic simulation. I've been working with it for probably 12 or so years, and it's just been getting better. We're going to be using the older style of dynamics, the first ones they started with, and then we're going to move into bullet dynamics, which is a little more, you can use more objects, and the dynamics, the original classic dynamics for Maya is fantastic, and it's still being used today, so I'm going to show you how to use those. So dynamics is a type of animation. That's where we get the advanced animation, right, and visual effects. So advanced animation, it doesn't come from me showing you advanced keyframe animation. It has to do with dynamic animation. So let's talk more about that. So dynamic animation lets you create realistic motion that's hard to achieve with traditional keyframe animation. It's not impossible, but you can't get the realistic or lifelike end result that you can from letting a computer actually create the physics that's actually recreating the physics that actually happens in real life. So that's what Maya is doing for you. Okay. Now you may have to tweak some things here and there, but other than that, it is pretty realistic. All right. So, for instance, you can make effects such as tumbling dice, waving flags, and exploding fireworks. All this kind of stuff is kind of background visual effects, or stuff that you would use in your animation, maybe to give it that little cherry on the top, or the icing on the cake, if you will. It's one of those things that you spend all your time creating animation for your character and getting all this really cool animation with your character. The last thing you want to do is, when you throw a ball, animate that ball hitting the side of a wall. Even though we start with the ball in character animation, just to get you ready for keyframing, you would not want to do a dynamic animate, or you would not want to to animate, keyframe animate, ball bouncing around, hitting maybe rolling a ball down a bowling alley and hitting a bunch of pins. You wouldn't want to do that. That's just something that, it's not beneath you, but it's just something you don't need to do, since there is dynamics in Maya. So what is a rigid body? Well, a rigid body can be used on any surface except you can use it on NURBS and polygonal. You can't use it on curves. Maya has two kinds of rigid bodies, active and passive. Active rigid body reacts to dynamics, fields, collisions, and springs, but not to keys. You cannot keyframe active rigid bodies. But on the other hand, with a passive rigid body, you can keyframe that, which makes it very powerful. Those two together is a powerful combination. Okay, limitations. Let's note those real quick. You can create only one rigid body per object or object group. Only one side of a rigid body surface can collide, the side with normals facing outwards. Now, I've discussed that in my videos. When we get farther down, I'll show you that, and you can watch that yourself. You'll get error messages, and rigid bodies may penetrate each other. Okay. Do not animate the scale or other deformations of a rigid body. A curve cannot be a rigid body, which we just discussed. A subdivision surface cannot be a rigid body. You can make a rigid body collide inside another, which is kind of interesting. Place the object inside the other object, reverse the normals or surface of the the object, and it should collide with it just fine. Okay. When you key a passive rigid body's translate and rotate attributes, the time slider doesn't show key markers. That's kind of an issue. That's kind of a bummer. But most of the time it does. When I was keyframing certain aspects, they do show up, and then there are aspects that won't show up. So you have to write them down. Okay, so with those, you need to use the graph editor to see the keys. You cannot remove keys on these attributes with the usual techniques. That means right-clicking over the time slider. Usually you can. Let me show you real quick. Here's the time slider. With keys, you're not going to be able to do it that way, but you could do it under Windows, Animation Editor's Graph Editor, and then select the keys here and delete them. Okay, you can do it in the Graph Editor. Okay. All right. So with rigid bodies, avoid using the Edit Duplicate menu item with duplicate input connections or duplicate input graph. Use the Dynamic Relationship Editor to connect the duplicate rigid body and fields. Basically, it's saying you can duplicate them, but you'll have to go ahead and reconnect with the Dynamic Relationship Editor. Okay. All right. So the active rigid body options is mass, static friction, dynamic friction, bounciness, damping, and impulse. So you can read through those. And I go through everything with the Introduction to Rigid Body Dynamics lecture videos. I expect you guys, even though I'm not grading you on this, I expect you to watch every one of them. This is kind of priming you up, and I want you to follow along with them. You don't have to turn anything in, but follow along with them and learn as much as you can before you start your assignment, because it can get a little crazy with rigid body dynamics. Even though we're only doing one specific thing, but we've got 4 other dynamic simulations things going at once, and things can get really crazy and out of control if you don't watch these first. Okay, so please watch those so you understand it. The course assignment, of course, that I'm going to expect you guys to model and texture this time. It's a very small scene, so don't get all in a tizzy because I'm making you texture this time. But I want you to texture this time, and because it is a small scene, I think you can handle it no problem. Okay. I expect you to model and texture the boxes as well. Okay. You're going to create a fire effect, a water stream effect, water simulation with particles. You're also going to create, don't forget this, some of you were like mulling around that you didn't need to add the second splash. So let me play that real quick. The second splash is that when the particles hit the box, they die off, and here's the splash and hits the ground. That's all controlled by the particle collision event editor. I will take points off, okay, if you don't add that and it doesn't look right. Okay, so just keep that in mind. And then when we do our the actual course assignment, this is where all your videos are from start to finish, how to get everything put together. Okay. Please start this early in case you run into issues. Emailing me Saturday and Sunday to say something's not working is not a good idea, especially for this class. Get this stuff done immediately. Have this be your primary assignment and get it done within the first day. Then it's totally possible to get this done in the first day. Once that's done, you're done with it. If you have questions, you can get a hold of me early in the week, which is it's something better for you, and it's better for me too as well, in case we run into something really serious that we need to fix, which I can't even imagine. The only thing that I can think of that could happen would be that you corrupt your scene file and you're trying to start it over again, like deleting the fields and deleting something else. Things get really corrupt really fast with using visual effects, like doing particle simulations, dynamic effects. Rigid body dynamics especially cause issues and problems and errors. And so if you make a mistake on that and something's not showing up, I was working on this project in particular, and I tried to go back and actually tried to delete the rigid bodies on the boxes, and it corrupted my whole scene. That's going to happen. If that happens to you, you have to basically open up a new scene and start over again. Okay, that's what you'll have to do. And if it continues, then you've got to go in there and delete preferences. Okay, if you've not deleted preferences before, I can show you real quick. Okay, so let me go in here and let me get into this, and I'll show you how to delete preferences real quick. Make sure Maya is shut down. So go into my PC, go into my documents, go into Maya, and go into 2020. You'll see that folder right there. And then right here, you just highlight it, right click over it, and delete. It's not going to hurt anything. Okay, I wouldn't delete anything else. Don't delete any other folder, just the prefs. Okay, it's called the prefs folder. And what you do is you delete that. And that's not enough. You'll have to go out and you'll have to double click on your trash can and delete it in there. You have to delete everything out of the trash can. Otherwise, Maya will find it in the trash can and will reuse it again. Okay? I've told you guys over and over again, Maya is self-aware. I truly believe that. No, just kidding. But it is funny that sometimes you wonder about that. Okay, so what else do we have here? We need to cover. Okay, so watch the videos. When you're all finished, congratulate yourself, pat yourself on the back, and I've kind of highlighted the things I want done. Okay, so the grading rubric. Alright, so the first one, put out the fire dynamic simulation. The grading rubric is the student add appropriately colored Maya Lambert materials on the objects. I've had a lot of people, a lot of students actually, that are not adding just regular Lamberts to the scene, so it's impossible for me to see this. So get this image in your mind. Okay, I don't particularly need you to put wireframe on shaded on. That's fine, you can have it off. The reason why I put it on is for you guys to see a little better when I'm doing examples and stuff like that and lecturing. So usually I want that turned off. Okay, you can have it on. I'm not going to take any points off if you have it on. But what I am going to take points off is that you don't add a basic Lambert. How hard is that to do? You go in here, select it, and you go to Assign New Material, and go to Maya, and click on Lambert, and add a color to it. That's it. That's all you have to do. Okay. Now if you don't texture, so that's 2 points off if you just leave it gray. Everything's gray, like you just modeled it, freshly modeled, and you did the simulations, whatever. That's 2 points off. Okay. Now, if you texture everything, then I take those 2 points because I figured that if you're texturing, you're going to go and add a Lambert anyway. You're going to have to add a Lambert, okay, to put the diffuse texture on there. So you lay out your UVs, actually lay out, add a Lambert to it, lay out your UVs, bring it into Substance Painter, pull the color image, if you do Substance Painter, and put it on there, and you're ready to go, okay? And it will show through here. Now, Lambert, we're not going to be using Arnold or anything. I'm not going to have you render anything, but you're going to be using Maya software for the render, and you'll be going through this and using the production quality, highest quality, and then Gaussian filter. Make sure you don't even have to have ray tracing on because we're not going to really render this. And your texture should show up in your scene. Some of you guys that have gone above and beyond every single time have had textures, and they show up just fine with your Play Blast. Okay? Do not use, and I repeat this, do not use AI standard surface materials for Arnold. We're not going to be rendering it in Arnold. Okay? All right? We're not even going to be rendering it. So anyway, to keep that in mind, if you go in and do a metal material, it will not show up in here properly. Okay? So if you're going to use a metal material, you're going to have to probably bring it into Photoshop and find a metal material and then apply it in Photoshop. You'll have to do the old school, bring the UVs in. If you're going to have a texture, an actual texture that has texture on it, not a metal, because chrome, as you know, is just basically black with reflection turned all the way up. So chrome will not show up at all, okay, unless you're rendering it with an environment and with Arnold. Okay? Alright? So just keep that in mind when you guys are going through that. Alright, so with my grading, let's continue with that. Just so you understand. Okay, so if you add a Lambert material, you're doing good, but not quite all the way yet. So if you do the material and don't do the modeling and texturing, it's 4 more points off. So basically what you'll have off is if you don't put a Lambert material on there and you don't texture them, you will have 6 points off. If you texture everything, you don't even have to worry about this. Okay? Okay, if you texture everything, no points off. If you don't texture, but you do put the Lambert on, it's 4 points off, not 6 points. Okay? So hopefully that's clear, because I kind of spell it out here again. Please note that if the student appropriately textures all the objects in the put out the fire simulation scene using Lambert materials as a base material, the grade deduction of 2 points will be waived. Okay? Alright, so you don't even have to worry about the 6 points off at all. Okay? But if you just add the color Lambert materials, which you can, you'll have 4 points off because you didn't texture it. Because I want it textured. Okay? That's up to you. Some of you guys have other things you got to get done, and you've told me that. So I understand that, but points will be taken off. Just be aware of that. You know exactly where they're coming from. Okay? So the next thing is the student will add dynamic rigid bodies to each box and applied a gravity field to the boxes. I'm being very specific here because I have to be, and you need that. The student created a fire effect to each box to simulate burning boxes, tweaked and attribute settings for a more convincing look. The student created a water stream effect that shoots out of the fire nozzle when the handle is animated back. Again, that's very specific, isn't it? And tweaked out the particle attributes for a realistic water simulation. You guys know how to create a realistic water simulation now. Okay? So you probably don't even need to watch that video, but I would watch it anyway. The student created a realistic water simulation where the particles hit the boxes, knock them over, and put out the fire. Again, that's very specific, isn't it? I'm not giving you a certain time limit to do that. Notice that there is no time limit. Okay? You have to make sure that when you do a play blast, if I give you a time limit, I literally have students take that literally, meaning that if I give you 100 frames, just because it took me 100 frames to complete the whole simulation, may not mean that you can do the same thing within 100 frames. So I get students that give me a play blast that's not completely finished. So that's why I leave it open. that some of you may go over 100, may go over 200. I ended up with 300. But I don't give you a limitation because I've stopped doing that because some of you take that too literally. And so what happens is that you give me a simulation's not complete, or you give me a play blast that you cut off the end of it because you literally think I meant that's 200 frames I'm going to take off. So don't think about it that way. It's open-ended. However long it takes you to go from A to B within reason. I don't want a 1,000 frame animation, of course, because you can do it within that time frame. But I'm not going to give you an exact number either. Okay. All right, so that's worth 20 points. The student turned in the completed, put out the fire animation as an MB file. Make sure that's turned in, and the play blast. Make sure you use Xvid. If you ever turn in an animation, I know that sometimes you guys are rushing, but make sure you compress this. Okay, at either Xvid or H.264. These are both excellent. Excellent compression ratios, and they have and quality is incredible. So use those, and you turned in all your materials following the instructions and deliverables. So that kind of sums everything up, and that's worth 16 points. Okay. You know what? Honestly, I can't even grade you without this. I can't grade you without this part. Okay. So I gotta have that to even grade you, to even grade the rest of this. All right. Okay. So, course assignment, turn in instructions. You guys know exactly what I want now. It's pretty simple. There's going to be two things that I have to have. Okay, it's going to be the scenes folder and the playblast folder. It's going to be your scenes file and your playblast file. That's how I grade you. Okay, and my instructor example is not textured. Basically, if I were to turn this in, I would get 4 points off. So I just wanted you to know that. I'm going to have one with textures in it, because that's easy to do. Take you maybe an hour. If you're not good at texturing, probably 30 minutes if you're good at texturing. So there's a 30-minute job there. Get the 4 points. Okay. This basically means that if I were to just leave this gray and did the simulation, it'd be 6 points off. You're done. You're finished. You got everything done. Go ahead and upload it. And I look forward to seeing you guys in Module 6. I hope you had a great week. I hope you had a lot of fun creating this dynamic simulation, and I will see you in Module 6. Have a great week.